Washington State transitioned to the 2005 National Electrical Code for testing purposes starting April 1, 2006. A crucial aspect to remember is that the questions in the electrical exams do not undergo drastic changes from one code cycle to the next. They are generally not heavily dependent on the specific version of the code. The journeyman exam in Washington State is now structured similarly to the administrator exam. The journeyman exam comprises two distinct parts. Firstly, there's the NEC and theory portion focusing on the National Electrical Code and fundamental electrical theory. Secondly, there is the RCW and WAC segment, which pertains to the Revised Code of Washington and the Washington Administrative Code, which are state-specific regulations. If someone taking the journeyman exam successfully passes one section but does not pass the other, a grace period of 12 months is granted to retake only the section that was not passed. This allows for focused preparation and retesting on the deficient area without having to repeat the entire exam. In Washington State, there are 3 primary electrical certifications and corresponding exams. These include firstly, the journeyman or specialty electrician certification. Secondly, the administrator certification, and thirdly, the master electrician certification. Within Washington State, a key requirement to be an electrical administrator is holding a valid electrical contractor's license. It's important to note that the administrator is not necessarily required to be a licensed electrician themselves. A master electrician in Washington State is defined as an electrician who has successfully passed the administrator exam. This signifies a higher level of expertise and knowledge encompassing both electrical work and administrative responsibilities. As of July 1, 2005, a significant change was implemented regarding the qualifications for becoming a master electrician. Testing is now a mandatory requirement to achieve this certification. Prior to this date, there was a grandfathering provision that allowed individuals to become master electricians based on their experience and qualifications without having to take the exam. However, this grandfathering period was time limited. The National Electrical Code, or NEC, is a comprehensive set of standards and guidelines for safe electrical installations. It is updated every 3 years to incorporate new technologies, safety practices, and industry advancements. Understanding the NEC is crucial for anyone working in the electrical field, as it provides the foundation for safe and compliant electrical work. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, equipment installation, and special occupancies. It is organized into chapters, articles, and sections, each addressing specific aspects of electrical systems. Some key articles in the NEC include Article 90, which covers the purpose and scope of the code, Article 100, which defines essential terms, Article 210, which addresses blunt circuits, Article 220, which covers feeder and service calculations, Article 250, which focuses on grounding and bonding, Article 300, which outlines general wiring methods, Article 310, which deals with conductors for general wiring, Article 400, which covers flexible cords and cables, Article 430, which addresses motors, motor circuits, and controllers, Article 450, which focuses on transformers, Article 500 through 516, which covers hazardous locations, Article 600, which deals with electric signs and outline lighting, Article 625, which covers electric vehicle charging systems, Article 680, which focuses on swimming pools, fountains, and similar installations, Article 690, which addresses solar photovoltaic systems, Article 700, which covers emergency systems, Article 701, which deals with legally required standby systems, Article 702, which focuses on optional standby systems, Article 705, which covers interconnected electric power production sources, Article 725, which addresses Class 1, Class 2, and Class 3 remote control, signaling, and power-limited circuits, Article 760, which covers fire alarm systems, Article 800, which deals with communications systems, Article 810, which focuses on radio and television equipment, Article 820, which covers community antenna television and radio distribution systems, and Article 830, which addresses network-powered broadband communication systems. Electrical theory is the foundation for understanding how electricity works and how to apply it safely and effectively. It encompasses fundamental concepts such as voltage, current, resistance, power, and energy. Voltage, measured in volts, is the electrical potential difference between 2 points in a circuit. It is the driving force that pushes electrons through the circuit. Current, measured in amps, is the rate of flow of electric charge. It is the number of electrons passing a given point in a circuit per unit of time. Resistance, measured in ohms, is the opposition to the flow of current. It is a property of materials that restricts the movement of electrons. Power, measured in watts, is the rate at which electrical energy is transferred or consumed. It is the product of voltage and current. Energy, measured in watt-hours or kilowatt-hours, is the total amount of electrical work done over a period of time. It is the product of power and time. Ohm's law is a fundamental principle that relates voltage, current, and resistance in a circuit. It states that voltage is equal to the product of current and resistance, or volts equals amps times ohms. This law can be used to calculate any of the three quantities if the other two are known. Series circuits are circuits in which components are connected end-to-end so that the same current flows through each component. The total resistance in a series circuit is the sum of the individual resistances. The voltage drops across each component add up to the total voltage of the circuit. Parallel circuits are circuits in which components are connected side by side so that the voltage across each component is the same. The total current in a parallel circuit is the sum of the individual currents. The reciprocal of the total resistance is equal to the sum of the reciprocals of the individual resistances. Series parallel circuits are circuits that contain both series and parallel connections. Analyzing these circuits requires applying the principles of both series and parallel circuits to determine the voltage, current, and resistance in different parts of the circuit. The Revised Code of Washington, or RCW, is the codified general laws of the state of Washington. It is a comprehensive collection of statutes passed by the Washington State Legislature. The RCW covers a wide range of topics including business, education, environment, health, labor, property, and transportation. The Washington Administrative Code, or WAC, is a compilation of the administrative rules and regulations adopted by state agencies in Washington. It provides detailed guidance on how state laws are implemented and enforced. The WAC covers a wide range of topics, including agriculture, business, education, environment, health, labor, and transportation. The electrical administrator in Washington state plays a crucial role in ensuring that electrical work is performed safely and in compliance with state regulations. The administrator is responsible for overseeing the electrical operations of an electrical contractor, ensuring that all work is performed by qualified personnel and that all installations meet the requirements of the NEC and other applicable codes. The administrator must have a thorough understanding of electrical theory, the NEC, and state regulations. They must also be able to effectively manage and supervise electrical workers. To become an electrical administrator in Washington state, individuals must pass an examination that covers electrical theory, the NEC, and state regulations. They must also meet certain experience requirements. The Master Electrician is the highest level of electrical certification in Washington state. To become a Master Electrician, individuals must first be licensed as a journeyman electrician and then pass an additional examination that covers advanced electrical theory, the NEC, and state regulations. Master electricians have extensive knowledge and experience in all aspects of electrical work. They are qualified to design, install, and maintain complex electrical systems. Master electricians often work as supervisors, project managers, or consultants. They may also own their own electrical contracting businesses. The grandfathering provision that was available for a limited time allowed experienced electricians to become master electricians without having to take the examination. This provision was intended to recognize the skills and knowledge of electricians who had been working in the field for many years. However, the grandfathering period has expired, and testing is now required for all new master electricians. Continuing education is an important aspect of maintaining electrical certifications in Washington state. Electricians are required to complete a certain number of continuing education hours each year to keep their licenses and certifications current. Continuing education helps electricians stay up to date on the latest technologies, safety practices, and code changes. The Washington State Department of Labor and Industries, or L&I, is the state agency responsible for regulating the electrical industry in Washington. L&I sets the standards for electrical licensing and certification, conducts inspections of electrical work, and investigates complaints against electricians and electrical contractors. L&I also provides educational resources and training programs for electricians. The NEC is updated every 3 years to incorporate new technologies, safety practices, and industry advancements. It is important for electricians to stay up to date on the latest code changes to ensure that their work is safe and compliant. The NEC is available for purchase from the National Fire Protection Association, or NFPA. It is also available online through various subscription services. Understanding the NEC is essential for anyone working in the electrical field. The code provides the foundation for safe and compliant electrical work. Electricians should familiarize themselves with the NEC and refer to it regularly when performing electrical installations. Grounding and bonding are critical safety measures that protect people and equipment from electrical shock and fire hazards. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and de-energizing the circuit. Bonding connects all metal parts of an electrical system together, creating a low impedance path for fault current to flow. Grounding and bonding are covered in Article 250 of the NEC. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from excessive current flow. Overcurrent can be caused by short circuits, overloads, or ground faults. Circuit breakers and fuses are rated in amps and are designed to trip or blow when the current exceeds their rating. Overcurrent protection is covered in Article 240 of the NEC. Wiring methods refer to the types of cables and conduits used to install electrical wiring. Common wiring methods include non-metallic sheathed cable, or NM cable, rigid metal conduit, or RMC, intermediate metal conduit, or IMC, electrical metallic tubing, or IMT, and flexible metal conduit, or FMC. The choice of wiring method depends on the application, the environment, and the requirements of the NEC. Wiring methods are covered in Chapter 3 of the NEC. Electrical boxes are enclosures used to house electrical connections and devices, such as switches and receptacles. The electrical boxes must be properly sized and installed to provide adequate protection for the wiring and devices. Electrical boxes are covered in Article 314 of the NEC. Conductors are wires that carry electrical current. Conductors are made of copper or aluminum and are insulated to prevent electrical shock. Conductors are sized according to their ampacity, which is the amount of current they can safely carry. Conductor ampacity is covered in Article 310 of the NEC. The electrical equipment, such as panel boards, transformers, and motors, must be installed according to the requirements of the NEC. Equipment must be properly grounded, protected from overcurrent, and installed in a safe location. Equipment installation is covered in Chapter 4 of the NEC. Special occupancies such as hazardous locations, healthcare facilities, and swimming pools have additional requirements in the NEC. These requirements are designed to protect people and equipment from the unique hazards associated with these occupancies. Special occupancies are covered in Chapter 5 of the NEC. The NEC provides a comprehensive set of standards and guidelines for safe electrical installations. It is essential for electricians to understand and follow the NEC to ensure that their work is safe and compliant.